Good day, engineers. So for this video, ang i-discuss natin is yung sample problem number 2 at still ito ay para sa topic na analysis of singly reinforced beam. So i-start na natin yung sample problem 2. So sabi dito, a beam is designed to resist a negative moment and has a dimension of 350 mm by 500 mm. Then this beam will be reinforced with 5 diameter 28 mm bars in 2 layers as tension reinforcement. The first layer has 3 diameter 28 mm bars and 2 diameter 28 mm bars for the second layer. The distance of the centroid of the first and the second layer bars are 74 mm and 127 mm respectively. If F prime C is 30 megapascal and Fy is 414 megapascal, determine A, the distance of the zero strain to the extreme compression fiber, and B, the strength reduction factor, and RC will be the ultimate moment capacity. So, we will start by drawing the beam. So, eto medyo meron siyang mali kasi yung reinforcement natin is nilagay natin sa baba. So, pero in-state kasi dito na it is going to resist a negative moment. So, dapat ang reinforcement niyan is nasa taas. So, nandito yung first layer, ito yung second layer reinforcement. So, dapat ganyan siya. So, ginawa ko, for this one na lang para mas madali natin malaman yung madali natin makita is tinayo na natin siya, pero the actual design should be this one kasi it is going to resist a negative moment. So for now, we have to determine yung the following A, B, and C. So ni-note ko lang yung pagkakamali kasi when we go to the design, kailangan natin na alam natin where is the reinforcement where is the tension reinforcement. So alam natin kung nasaan ang reinforcement kapag negative yung moment and nasaan yung reinforcement kapag positive yung moment. So for this one, syempre sabi doon dalawang layers yung reinforcement mo. So on the first layer, meron kang tatlong diameter 28 and on the second layer, meron kang dalawang diameter 28. Then isa pa, binigay na yung distance ng centroid ng bawat isang layer. So sabi, the first and the second layer, so syempre, meron dong word na respectively. So ibig sabihin, ang first layer is 74 mm. Then, yung second layer natin, so magdagdag tayo ng kulay ng highlighter. So, ang second layer natin is ito. So, that will be 127 mm. So, ngayon, since dalawang layer yung reinforcement natin, so ito siya. So, meron tayong 5 diameter na 28. So, syempre, ang una natin gagawin is hanapin si D at hanapin si DT. So, syempre, para mahanap natin yung D, kailangan nating hanapin yung centroid nung 5 diameter 28 na reinforcement. So, magagawa natin yon by the principle of de Varignon's theorem. So, i-zoom in natin to. So, ito siya, yung next figure. So, pag sinum in natin yan, ito yung itsura. So, syempre, yung centroid ng reinforcement natin is papangalanan nating Y bar. So, kinuha na natin siya on the extreme tension fiber. Then, 74 mm yung centroid nung first figure kasi that is from the extreme tension fiber. So, next one will be 127 mm from the extreme tension fiber. So, syempre, to solve this one using the Barignon's theorem, so that will be yung area ng first layer times yung centroid niya papunta sa baba, and yung area ng second layer times yung centroid niya papunta sa baba. Then divided by the summation of the areas. So that will be y bar is now equivalent to a value. So first layer natin, that is tatlong diameter 28. So that is 3 times pi over 4 times 28 squared. Multiply natin dun sa distance niya from the extreme tension fiber, which is 74. Plus, syempre yung second layer natin may dalawang diameter 28 dun. So 2 times pi over 4 times our 28 squared. Times yung distance niya from the extreme compression fiber. So that is 127 divided by yung total area niya, which is 5 times pi over 4 times 28 squared. So our y bar now will be equivalent to a value of 476 over 5. So this is in mm. So yan ngayon yung ating distance na y bar or yung centroid ng ating reinforcement. So ibig sabihin, para makuha natin yung D, i-minus lang natin yung total height dun sa y bar. So we will have yung total height natin is 500 mm. Minus the value 476 over 5 mm. So, ang value natin for our effective depth is 2024 over 5. So, ito ngayon yung effective depth natin. Then, yung hinahanap natin na D sub T kasi for the net tensile strain, so that is just H minus 74 mm kasi that is the distance of the centroid ng first layer to the extreme tension fiber. So that will be 500 minus the value 74. So our D sub T now will be equivalent to 426 mm. So ito ngayon yung ating D sub T. Now we can proceed to the analysis of singly reinforced. So syempre, we will always assume that steel yields. Then after assuming that steel yields, we can get the stress diagram. So dito natin kukunin yung static equation na C is equal to T. So i-check natin yung compression. So yung compression side natin wala namang butas. So ibig sabihin valid pa rin yung 0.85 F prime C AB na compression force. So that will be 0.85 F prime C A theoretical times B is equal to AS. Since we are assuming steel yields, we will get Fy. Then we arrange the term, so that will be A theoretical is equal now to a value ASFy over 0.85 F prime CB. So we just get first the value of our AS, so that is 5 times pi over 4 times 28 squared. So our AS will have a value of 980 pi. So since meron na tayong AS, so we can compute the value of our A theoretical. So that is equivalent to, si AS natin is 980 pi. Then multiplied to the value of our Fy, which is sabi doon, that is 414. Then divided by 0.85 F prime C, which is, so that is F prime C, which is 30. So times 30 times the value of B, which will be 350. So we have now a value of A theoretical equivalent to 142.8131. So that will be a value of our A theoretical. Now we can proceed in getting the value of our C theoretical. So si C theoretical natin, manggagaling lang yan from the provision of the NSEP that A theoretical, or the value of A, is just equal to beta 1 C theoretical. And arranging the term, we can have C theoretical is equal to A theoretical over our beta 1. So, syempre, hanapin muna natin si beta 1. So, as you can see, our F prime C is 30, which is much greater than 28. So, papasok yung beta 1 natin on a value which is equivalent to 0.05, or that is 0.85 minus 0.05 times F prime C minus 28 divided by, so that is 7. So, dyan natin ngayon kukunin yung value ng beta 1 natin. So, that will be beta 1 is just equivalent to a value 0.85 minus 0.05 times 30 minus 28 divided by 7. So, we can have a value of beta 1 equivalent to 117 over 140. So, yan ngayon yung value ng beta 1 natin. So, getting the value of our C theoretical from that one, we can have C theoretical equivalent now to 142.8131, which is our A theoretical divided by 117 over 140. So, our C theoretical will be equivalent to a value of 170.8875. So this is in mm. So now, since we have determined the A theoretical and C theoretical, we will now proceed in getting the actual steel stress or the theoretical steel stress, so we could verify if our assumption is correct that steels are yielding. So to check, we will be needing the strain diagram. So syempre, pag dinrawing natin yung strain diagram, since 2 layer na yan, so meron tayo ditong 0.003 at nandito yung epsilon sub s natin at ito yung epsilon sub t. Then this one will correspond to our C theoretical, and this will be yung D lang natin yung kailangan natin. Then this will correspond now to D minus our C theoretical. So, syempre, using the similar triangles and yung epsilon sub s natin dyan is equivalent to a value fs over our es. So, that will be 0.003 divided by our C theoretical is equal to our value fs over es divided by d minus C theoretical. So, yan ngayon yung equation natin. So, syempre, same pattern kagaya ng ginawa natin from our previous sample problem. So, magiging Fs lang to is equivalent to 0.003 Es times D minus C theoretical divided by the C theoretical. So, that will be Fs now na theoretical natin is equal to, so, syempre, yung Es dyan magiging 200,000. And if we multiply that by 0.003, it will yield a value equivalent to 600 times D minus C theoretical over C theoretical. So, substituting the values, so that is 600 times yung D natin na kinumpute kanina, which is 2024 over 5. That will be 2024 divided by 5 minus yung C theoretical din na nakompute natin, which is 170.8875 divided by 170.8875. Now, our Fs theoretical will be equivalent to a value of 821.2859. So, as you can see here clearly, this is greater than our Fy, which is 414 megapascal. So, we can say that this is, our assumption is correct and stills are yielding. So, ibig sabihin, we can say na etong Fs theoretical natin na to is equivalent to our Fs actual, and yung A theoretical natin is also now equivalent to our A actual, and yung C theoretical natin is now equal to C actual. So, yung pinadedetermine sa atin is the distance of zero strain to the extreme compression fiber. So, that is C. So, yung C natin is ibabox natin since siya yung required. So, our C actual is now equivalent to 170.8875. So, that is in mm. So, ito yung isang required natin. So, next to determine, since na-prove na natin and tama yung assumption natin that stills are yielding, so we can proceed in calculating yung epsilon sub t, which will be used to calculate our reduction factor. So, to calculate epsilon sub t, syempre kakailanganin natin yung strain diagram natin. So, syempre, tamang-tama to. This is a two-layered beam or two-layered singly reinforced beam. So, magagamit natin yung epsilon sub t kasi magkaiba yung dt at d natin. So, syempre, this will correspond to our C actual. So just a reminder again, okay lang na kabisado nyo yung formula, pero much better if you can get it from the strain diagram and the stress diagram alone, para pag nakalimutan nyo ng yung formula is masasagutan nyo pa rin yung problem. So then this will be dt. Syempre dt na to, and this will be a height dt minus C actual. So now we can determine epsilon sub t coming from this diagram. So similar triangles lang, we can have 0.003 divided by the C actual is equivalent now to the epsilon sub t divided by dt minus RC actual. So, arranging the term, our epsilon sub t will be equivalent to 0.003 times dt minus C actual divided by our C actual. So, our epsilon sub t now is equivalent to 0.003 times our dt na nakuha natin kanina, which is 426. So, that is 426 minus RC actual, which is 170.8875 divided by, so that is 170.8875. So our epsilon sub t now will be equivalent to a value of, that is 0.004479. So this is, as you can see, this is lesser than our 0.005, and kunin natin yung epsilon ty. So our epsilon ty is the value 414 divided by 200,000. So tama, ang FY natin is 414. So that is 414 divided by the value 200,000. So yung epsilon ty natin dito is a value, so that is a value equivalent to 0.00207. So syempre that is still yung mas greater yung epsilon sub t natin. So as you can see here, we are still on the transition zone. So, syempre, pag kukuha tayo ngayon ng reduction factor, nandito tayo sa line na to. So, that means it will still be, so, syempre, that is kukunin pa rin natin yung equation of a line. So, syempre, y is equal to mx plus b. And this point will correspond now to ang epsilon ty natin still, since ang fy natin is 414. So, that is 0.00207. And yung corresponding y niya is 0.65. And for this point here, we have 0.005 and 0.9. So, yan ngayon yung line natin. So, kunin ulit natin yung rise over run yan. So, syempre, that is m is equal to 0.9 minus 0.65 divided by our value 0.005 minus 0.00207. So, that is the rise over the run. So, that is equivalent now to 25,293. Or 25,000 divided by 293. So, yan ngayon yung slope natin. So, to determine the y-intercept, syempre, substitute lang natin yung isang coordinate. Piliin na natin yung 0.005 and 0.9. So, that will be 0.9 is equal to 0.00, lagyan na muna natin yung slope. So, that is 25,000. over 293 times 0.005 plus b. So our y-intercept will be equivalent to a value of 1387 over 2930. Ito na ngayon yung ating y-intercept. So, syempre, we set y equal to reduction factor and we set x equal to the epsilon sub t. So, we can have the reduction factor equal to 25,000 over 293 times epsilon t plus 1387 divided by 2930. So, substitute lang natin yung epsilon sub t na nakuha natin kanina. So, yung 25,000 over 293 will be multiplied to 0.004479. So, plus 1387 over 2930. So, our reduction factor now will be equivalent to a value of 0.8555. So, yan ngayon yung ating reduction factor. So, now we can proceed in getting our nominal moment by using our stress diagram. So, syempre, kunin lang natin yung stress diagram sa taas. This is just the same. So, itong stress diagram na to, ito ngayon yung gagamitin natin to get the nominal moment. So, to get our nominal moment, we can have m sub n. So, kunin pa rin natin on the tension side. Pwede rin naman on the compression side. Mag-equal lang naman yon. So, that will be T times the moment arm D minus A over 2. So, T will be equivalent to AS times Fy. Kasi we have proven that steel yields times D minus A over 2. So, RMN will just be equivalent to yung AS natin kanina, which is 980 pi. So, 980 pi times yung Fy natin, which is 414, and times yung D natin kanina, which is 2024 over 5. Minus yung A natin na nakuha, na actual na, which is, sabi natin, that is 142.8131. 142.8131 divided by 2. So, multiply natin ng 1 over 1,000 squared para yung unit natin is in kilonewton meter. So, our Mn now will just be equivalent to a value of 424.9456. So, this is in kilonewton meter. So, syempre, yung ultimate moment natin is makukuha lang natin by multiplying our reduction factor with the nominal moment. So, the reduction factor na nakuha natin kanina is 0.8555 times the nominal moment 424.9456. So, our ultimate moment now will be equivalent to a value of 363.541. So, this is in kilonewton meter. Ito ngayon yung hinahanap natin na ultimate moment, at yung isang hinahanap is yung ating reduction factor, which is 0.855. So, we have determined all the required in sample problem number 2. Andyan na yung ultimate moment natin, yung reduction factor, at yung distance from the zero strain to the extreme compression fiber. So, that will be all for our sample problem number 2. Again, this is Engineer Rodolfo. Thank you for watching and don't forget to subscribe to Butch TV.